Hi. We're going to take the last page or the last set of notes over section 2.6 today. And so I wrote out some of the notes because let's face it, I'm not great with technology. And then we will, so I'll kind of talk you through those. If you need to pause the video so that you can get something written down, please do that. I'm trying to make the video as short as possible because you do have the pausing capability. So let's get started. The first thing we're going to do is talk about how to graph rational equations rational functions. So there's a strategy that we use. Here are the steps for that. So there's the strategy. You're first going to find the y-intercept. We do that by letting x equal 0. Next, we find the x-intercept or intercepts. We let f of x equal 0 and solve. And I put ... there because I need to remind you that when we're dealing with a rational function, we have a fraction, so we're making a fraction equal to 0. The only way that fraction can be 0 is if the numerator is 0, so we really only have to set the numerator equal to 0 to find the x-intercepts. Then we'll find any vertical asymptotes. Again, that's by setting the denominator equal to 0 after the fraction has been simplified completely. And then we'll find any horizontal asymptotes if there is one. And again, that has to do with the degrees of the numerator and denominator. Then it says we're going to plot one point between and beyond each x-intercept and vertical asymptote. So we kind of have to fill in the gaps a little bit. So it's nice between steps 4 and 5 if you go ahead and make a little, go ahead and start sketching the graph, then you can kind of see where do you need to fill in some information. Okay. So we're going to look at an example. Here it is. F of x equals 2x minus 1 over x minus 1. So you can see how I found the y-intercept by finding f of 0. There's the x-intercept. We make the function equal to 0, but remember we just talked about the only way that this fraction can equal 0 is if the numerator is 0. So here I've set the numerator equal to 0, which gives me this solution, which gives me this ordered pair. And so I said that again here. Then we look for vertical asymptotes, set the denominator equal to 0. X equals 1 is our vertical asymptote. The horizontal asymptote, in this case, the degree of the numerator is the same as the degree of the denominator. So we take the leading coefficient of the numerator divided by the leading coefficient of the denominator. So that's 2 over 1. Or we end up with just y equals 2. At that point, I'm going to go ahead and try to draw a sketch. Well, and I ended up drawing the whole thing. But I would have drawn the asymptotes in there and as well as the x and y intercepts. And I'm going to realize or recognize that, I need to turn around here and look at it a little bit. Let me look. The y-intercept being 1, 0, okay, so that's down here, and the x-intercept being 1/2, 0. Oh, which is down here. Sorry, this is the y-intercept. Here's the x-intercept. Okay, those are the only 2 points I had. So I could pretty much draw this piece of the graph. That's great. But I had no information on the other side of this vertical asymptote. So I needed to choose some points beyond this side of the vertical asymptote. So I chose to look at x equals 2 and x equals 3. I also went ahead and just tried to find, well, what's happening at x equals -1, right? So I want to know, well, what's happening maybe over this way, just to make sure that I have a pretty clear picture. Once I have all those ordered pairs, I'm going to graph, and it's going to be nice, and we know as we approach asymptotes that we're either going towards the asymptote if it's horizontal, or we're going towards positive or negative infinity if it's vertical. So again, if you need to pause to get all that written down, that's great. Go ahead and do that at this time. Perfect. Let's look at another one. We have this one, f of x is 2x squared over x squared minus 9. Again, find the y-intercept by making x 0. We get 0, 0. Well, if the y-intercept is 0, 0, the x-intercept is also 0, 0, right? That's the same thing. To find the vertical asymptote, we make the denominator equal to 0. I solved that, got those two vertical asymptotes. Here we have a horizontal asymptote. Again, the degree of the numerator is the same as the degree of the denominator. Therefore, we have the leading coefficient of the numerator divided by leading coefficient of the denominator, which is y equals 2. Again, start trying to draw that sketch. We would have all those asymptotes on there, which would be good. We would have only really 1 point, which would have been 0, 0. So we need to find out some more information. I probably want to get a little bit of information on each side of that x-intercept. Okay, so between this x-intercept and this vertical asymptote, and also between this x-intercept and this vertical asymptote. Then also we need to find out what's going on this side of the vertical asymptote and what's going on over here. So I actually had to choose quite a few points. In fact, I chose 5 just so I could have a really good picture. Okay, so I chose to find out what's going on when x is -4, x is -5, so I'm getting all the stuff that's going on over here. I'm looking at x is -1 and 1. That's telling me what's going on here on both sides of my x-intercept. And then finally, I chose 4. Maybe I didn't choose 5. Did I say 5? I probably would have done 5. Looks like I did there. So I'm going to find that also, and I'm going to go ahead and graph that, and then that's going to give me a really nice picture of what's happening. Okay. All right, so that's the stuff about graphing. We're still going to be graphing a little bit, but we also need to talk now about something called slant asymptotes. So remember last time we said that when the degree of the numerator was greater than the degree of the denominator, there are no horizontal asymptotes. Instead, we have what we call slant asymptotes. So to find a slant asymptote, divide the rational expression, hopefully with synthetic division, because that's the easiest way to divide. The quotient, not including the remainder, so we sort of ignore the remainder in this problem, will be the equation of the asymptote in y equals mx plus b form. Okay, so we're going to look at an example of that. Here is the function 2x squared minus 5x plus 7 over x minus 2. So again, we start the same process. We're going to find the y-intercept. Here it is. Find f of 0. That happens to be -7/2. We're going to look for x-intercepts. And you can try this. If you use the quadratic formula to solve this, you're going to find out, because it's not factorable, then you're going to find out that that's going to give us actually imaginary numbers. And so there are no x-intercepts. Interesting. We have a vertical asymptote. Let the denominator equal 0, x equals 2. Horizontal asymptote. The degree of the numerator is greater than the degree of the denominator. Therefore, there are no horizontal asymptotes. Instead, we will have slant asymptotes. So now I'm basically dividing this. We're using our synthetic division because I can. So inside the box, I have 2, -5, 7. Outside the box, I have +2. We go through the synthetic division and we get this, the 2, the -1. So we write our equation y equals 2x minus 1. Okay, so that's all of the information that we're going to put on the graph to begin with. Okay, let me get that. Maybe. The papers are sticky. I'm trying. Turns out I'm not good without technology. Okay, here we go. So far, I went ahead and just put on there what we know so far. We have a vertical asymptote that I've graphed at x equals 2. We have a y-intercept of 0, -7/2. That's like -3.5, so it's right here. We do not have an x-intercept. We do have a slant asymptote. Remember, y equals mx plus b. I started at the y-intercept, which was -1, up 2 over 1, up 2 over 1 to get some points and draw a nice slant asymptote. So that's all I know so far. But we're going to need some more points. In fact, I really only know 1 point, and it's right here. So I need to know maybe what's going on the other side of this point. I also need to know what's going on this side of the vertical asymptote, because I don't have any points on this side of the vertical asymptote. So you want to make sure always that you look at your vertical asymptotes and make sure you have points on both sides. So these are the points that I chose to find. We need x equals 1, we need x equals 3, and we need to find out what's happening when x is 4. So x equals 1, I'm going to find out kind of what's going on over here. So I have this point and this point. That's going to help me know what's going on in between these asymptotes. X equals 3 and 4 is going to help me know what's going on this side of the vertical asymptote. So that's what's going on. There are the ordered pairs. Okay, 1, -4, 3, 10, and 4, 19 halves, or about 9 1/2. So I'm going to put this down for a second. I'm going to graph those points. So just hold tight. 1, -4. We've got 3, 10, which I'm actually going to run off my graph. And we have 4, like 9 1/2. And this one is kind of interesting, and you'll kind of get the feel for what's happening with some of these types of graphs that have slant asymptotes. I have the points graphed. I could actually find more points if I wasn't sure. But I'm going to remember that as we're approaching vertical asymptotes, we're either going to positive or negative infinity. Well, in this case, I really can't go to positive infinity. I've got another asymptote that's kind of impeding that. So it must go to negative infinity, and this one must also turn back around. So you can imagine that this piece up here is doing sort of the same thing. I'll draw that in a little bit. It's not going to be fantastically a lot, but you'll get the picture. Actually, I'm going to show you the one that I have in my notes. It's a little bit better graphed. It looks like this. Okay. Okay, so we found all of those extra points, and then we were able to graph them, and that's what the graph looks like. Okay, hopefully you got all those notes. Again, you can rewind, you can pause, you can do whatever you need to do. Watch them again if you need. But here is your assignment for this portion. Still in section 2.6 on page 355, you're going to do 47 through 77 odd. You will need to take 2 pieces of graph paper if you want to use the graph paper. Of course, you don't have to. If you would like to just draw your own, but I have copied graph paper for everyone. So if you want to use it, be sure you take 2 pieces. I will have another video for you on Wednesday to watch over the next section, and hopefully then when I'm back with you on Friday, we'll get everything cleared up and make sure that we're all on the same page. Have a great day. See you later.